May I present to you Mr. Izmir Yamin, the founder of Independence X Aerospace and Pulsar UAV.
I'm here today, it's just a little sharing session of what we are currently doing. We've been a special interest project group started in the year 2003. And during that time, we started to think of a particular technology that we want to invest our time and money, and moving forward to see in the future what can we best do with it. Across the human history, there are two milestones, especially in this modern era, modern civilization era. There are two milestones that we hit to achieve what we have today, down to the latest core technology that you have in your pockets called the smartphone. So what are they? There are two things, transistors and rockets. These are the two core technologies in the world that won't go obsolete starting from the time that it was created. So based on the Wall Street Journal, this is a technology roadmap. So we've been thinking, what kind of technology should we be involved in? If you see, there are very common technology that started off from the industrial era since the invention of the steam engine. In early 1900s, there were this traditional technology that started off as AM radio, FM radio, television, and telephone. These four quite old technologies since the early 1900s. However, it started to speed up rapidly in the early 1960s, late 1950s with the invention of high-frequency transistors. So during that point, a lot of miniaturization took place. So if you see, transistors has affected a lot of devices since radio communications, televisions, telephones, audio, down to very miniature size. However, the space program came in just a couple of years later to really push it to the limit and boundary. The entire Apollo spacecraft capsule that has all the computers on board is equivalent to your smartphone power of processing. So for us, what we're trying to do is we're trying to pick either one of them. Because we thought if a nation wants to move forward to be developing new technologies and pushing the boundaries and frontiers, they need to have either one of these in their hands. So for our company, when we started off as special interest group, today we are a company, we decided to go with the path of aerospace propulsion systems, whereby one day we would like to have launch as a service of launching satellites into space. In 2013, we established a company called Independence X Aerospace. We are based in Technology Park, Malaysia. So we are looking at different methods of propulsion in space. One of them is called electric ion propulsion, which means you can travel into space at relatively much lower cost and much lighter mass. However, it is not feasible for you to launch from ground to space. You need to use chemical propulsion instead. So we decided to go on both paths, chemical propulsion and electric propulsion. Okay, the company vision is based on the reason why we're doing this. The number one reason is the application back on Earth. But the mission right now is we are trying to develop a technology demonstrator whereby we decided to go an interplanetary mission based on private funded missions. So that is to go to the moon. And our vision is to see if we can push the boundary of this technology to go to Mars. We are currently developing a system called the Dedicated Nano Launch Vehicle, which is for short is DNLV. It is meant to launch smaller satellites called CubeSats into space. Instead of having a large rocket to launch bigger satellites, we are planning to build a smaller rocket that is 1/3 or 1/4 of the conventional size rockets. The DNLV rocket has been accepted and published in NASA report in 2015 in December. So we are having in constant verification with NASA. So therefore, most of the companies who wants to launch their CubeSats at relatively much lower cost, they will be looking for companies like us. There are only 2 companies in the world who's doing this. One is in New Zealand, they're called Rocket Lab, another one is us. So what are we doing is, we are trying to bring down the cost of launching from 200,000 US dollar per kilogram down to less than 3,000 US dollar per kilogram. So it is possible using various methods of technology that we are currently developing. So our rocket will be fully electric driven pump instead of a hot gas turbo pump. So it's a kind of innovation that we are coming up with. Launch as a service that we intend to provide with our rockets is actually meant for various missions into space. One of them can be microgravity research. Another one can be launching communication satellites into space. With our rocket, it is not possible to go into the higher orbit, which is called the geostationary Earth orbit, or GEO, which is typically what communication satellites will be at about 37,000 kilometers in orbit. But what we intend to do is launch near the LEO, or low Earth orbit plane. Okay, so this particular orbit is beneficial if you want high-speed connection. When you launch at GEO, your connection speed will be roughly about 0.24 seconds. If you launch at LEO, you will have about 50 milliseconds or less, which is close to real time. But the drawback is GEO, since the latency is so high, it's not suitable for real-time data. But LEO latency is quite low. There you get real-time. The problem is you only have an overpass of about every 90 minutes. So what we plan to do is we plan to launch a constellation of them so that they can have relay, just like your telco tower when you're driving your car on the road and you will pass by a few telco towers. So same concept with this a constellation of satellite. I have developed a few technologies which won us a gold medal. So we were so keen on the propulsion system, looking into alternative ways on how to get to space cheaply. And then since 2003, we developed the solid fuel rocket just as a technology demonstrator, and then we upgraded it. We managed to launch to 2.7 kilometers. And then currently we are moving forward with our fourth prototype, which we intend to test it in space for our interplanetary missions. And then I was also working as a structural and design engineer for Airbus aircraft. I was designing the A380 and A320. And also, right now, I'm working on this project in full-time mode. Okay, so these are the glimpse of a few of our tests. By the way, those cars that you see there was actually built from scratch and is using a hydrogen fuel cell power, the same technology that we will use on board our rocket to run the turbo pumps. Basically, those are brief history that when we started to use alternative fuel in launching our rockets. So those two were solid fuel. And the last is, the Independence tree is liquid fuel. Okay? So when we look at the sky in night, a lot of people dream of wondering what is out there and whatnot. But for us, we are looking that as to be inspired to go out there and explore the boundaries of space. So we decided to enroll into a competition called the Google Lunar XPRIZE. We got accepted in 2007 out of the 8,000 applications worldwide. So we were one of the 34 teams who got accepted back then. And then the mission is to safely land a rover on the moon and travel 500 meters and then take high-definition images and videos and transmit back to Earth. Okay, one of the main reasons why people choose to go to the moon back in the 1960s, besides winning the Cold War, is trying to find fuel for fusion, which is still in theoretical, but they are looking for helium-3 as a source of fuel for fusion cycle. It's the alternate for the current nuclear plants. Okay, and then secondly is an outpost on the moon to start to explore other planets, which will save you a lot of fuel and effort instead of launching all the way from Earth to wherever you want to go. Okay, another good reason is the moon itself is a good solar reflector that could reflect both sunlight and radio communications. Okay, so when we got accepted in Google Lunar XPRIZE, it started in 2007, and then now time has passed. We are the final 16 out of the 34. We're the only team in Southeast Asia. It's quite tough because this competition does not allow you to get government funding, only private. So we had a lot of difficulties in kick-starting a project related to this competition. So what we tend to do is we tend to have a parallel work plan. One is to maintain our ambition of developing our dedicated nano launch vehicle, which will be completed much later date, whereas this competition's deadline is by end of next year. So with that, the business plan of how we get this done is based on the dedicated nano launch vehicle. Okay, so to get this competition up and running, we decided to use our past experience and leapfrog towards developing the fourth prototype engine, which is called the Independence 4. And we are using very low cost and cheap material, whereby it's called silicon nitride, by the way. And instead of using silver and titanium alloy, we decided to use silicon nitride, where the cost is 100 times cheaper than the existing manufacturing process, and it works. So this engine will particularly power up the spacecraft that will be departing from orbit around the Earth and moving towards the moon. The distance of Earth and moon is roughly about close to 400,000 kilometers. And there are various ways on how do we get there with cost-effective method. It's called a slingshot effect. But before we do that, we need to select our launch provider. As of, we don't have any rockets right now. It's not yet been completed. It will take at least about 5 years from now. So we decided to go on board with a third-party launch provider and only look into developing the spacecraft itself. So we've been doing a lot of window shopping. And we saw the cheapest launcher is India. It's about 80 million US dollar. But these numbers only represent for their own lunar mission. For the launch that we are getting, we managed to get a good deal of 20 million US dollars for the launching price. And the cost of developing our spacecraft will be roughly about 3 million US dollars. Okay, so this is the rocket. It's called PSLV, or Polar Satellite Launch Vehicle, that will be launching from Sriharikota, India. So if we manage to pull this off by launching on the cheapest rocket, by the way, this rocket has a reliability of second ranking in the world after Soyuz. If we manage to pull this off, our mission, moon mission, will be the cheapest in the world history, which will be in total about 24 million US dollars. Okay, the spacecraft that we are looking at here is an hexagonal shape that will be fitted on board the rocket provider, the payload section, and it will be released in a low Earth orbit. Then the main engine, as you see at the bottom there, will kickstart firing up using hypergolic propellant, which is two chemicals. Upon mixture, it will self-combust. So these chemicals will fire precisely at the right amount of force and right amount of time to create a motion called orbit. So the orbit will be a circular, and later on will be an elliptical orbit. So in order to get to the moon cheaply, we have managed to calculate, and it wasn't easy for us to come up with this calculation. It took us quite a while, because to figure out the method of going to the moon, it's not just direct flight. There's a method called patch conic. If you notice in mathematics, when you take a cone and you slice them up in many different ways, you get circular, you get ellipse, you get parabola, and so on. So, in order for us to get to that point, it took us quite a while until we understood the fundamental principles of momentum. Then we make a slingshot at orbit number 1, increase the momentum, transfer to orbit number 2, again increase, go into 3, and eventually go to 4. By the time we reach the 4th orbit, where it will intercept with the lunar sphere of influence, then we may have to slow down to be captured by the moon's gravity. Okay, this method has been tried by 2 agencies. However, their cost is still high, and we have some plans to launch it at a specific time, which is called the launch window. Okay, for communications, because it is so far, so people be wondering how big an antenna it should be. If the antenna to be equal size both on the spacecraft and on Earth for those 2 devices to communicate, it should be 7 or 8 meters diameter size of antenna on each side. But that doesn't make sense. You want to launch an 8-meter antenna into space. So what we do is shrink down the size of one side, which is on the spacecraft, and enlarge the size which is on the ground. So that is more feasible. So on the spacecraft, we managed to get about 0.5 meter in diameter, and on the ground, we managed to secure about close to 17 to 18 meters in terms of diameter. But it's quite hard to get that kind of size. But okay, so then the energy required for the smaller antenna on board the spacecraft will be much lesser than on the ground, where it will be superly huge. You're talking about 10 kilowatts of power. When we send the spacecraft into orbit, it will always have this perturbation because due to irregular gravitational field that is happening across on the planet. So you need correction, attitude controls. So in order for the spacecraft not to go off your desired orbit, otherwise it will either deorbit or it will just go to a higher orbit. Okay, so once we land on the moon, we won't deploy any rover because we have done few designs, including a rover design, which we were so excited about. And then there are other problems such as getting to deal with the lunar dirt. The lunar dirt is called regolith, and the texture is almost like a talcum powder. So for you to deal that with the wheels that you are going to design, and remember the steering is quite difficult if you want to do a steering method. So we decided to go with skid to steer, but still it will cause other problems. So therefore we decided to ditch the rover idea and go with the first lunar drone. So basically the same spacecraft that will touch down, it will take off again at about 6 meters and move forward using a thruster, a small thruster, plus the main engine that's being fired to 6 meters. It will hover and move forward for 500 meters and land. Once it does that, take pictures, and then it needs to send back. Once Google receives it, then we are declared the winner, that we can win about 20 million US dollar. Since the cost is 24 million, so we are at a loss of 4 million. However, there are bonus prizes, such as finding water. I don't know why they want to find water. They told us that they want to put a human outpost over there and turn it also to rocket fuel and plant some vegetables. But anyway, we're going to get 5 million US dollar if we manage to find water on the moon. So, other than that, there are other bonus prizes like lunar heritage sites, such as the Apollo landing site or the Russian lunar Hot landing site, or the recent Chinese Chang'e missions. Okay, so once we manage to find those sites, we also get bonus prizes, like 1 million each. If we manage to do that, then it's a win. So we will cover most of our costs. Okay, so in order for us to detect the distance that we travel, normally we use an odometer if we're here on the ground. But on the moon, since we are not roving the ground, so we are using a LiDAR system, which is using lasers. Okay, The Google Lunar XPRIZE, even though it started in 2007, which a prize funded by Google, the idea. However, we have to owe back to an earlier prize called the Ansari XPRIZE. I'm sure most of you have heard the Spaceship One, Bert Rutan and Richard Branson, who bought over this company called Scale Composites, and they turned into Virgin Galactic and selling a ticket price of 200,000 USD of whoever wants to go into the age of space. So this company basically started by these two brothers, Bert and Dick Rutan. They are aircraft builders. So they built a lot of aircrafts in their garage and backyard. And later they joined a prize called Ansari XPRIZE, which is a 10 million US dollar prize. And they decided to build this spaceship. Looks like an aircraft, but it's actually a glider that literally went into space. Because for you to be qualified to be an astronaut, if you go to space, once you reach the Kármán line, which is 100 kilometers, you'll be declared as an astronaut. But since our mission is unmanned, so it doesn't matter. Okay, so this particular competition basically ignited the possibilities of a lot of people around the world, thinking that technology, the only barrier to it is knowing where are the intersecting points in the new modern technologies. As we look at the transistors and rocket technology, how they impacted the development of new technologies such as PCs, smartphones, and the internet. So the 1960s period has converged a lot of these technologies to be developed starting from that era. This is why we decided to look at this as part of our obligation. On the other front, if we can have a means to launch satellites into space, connectivity will be looked at in terms of covering all the rural areas. Putting into perspective, if you want to launch a shoebox-sized satellite, you don't send a 20-footer lorry. You know, we just put on a motorbike and go. So that kind of analogy we're doing. We're making a smaller launch vehicle, which is just enough for smaller satellites. Okay, so I will end by saying all of you can start making a change by doing great things with simple tools. So all back to understanding the timeline and history. So instead of going to the future, you take a pause, go back to the past and look where were the intersecting points and try to make a change from there. Okay, thank you very much.